Yeah, like Kingston's not here. I do have a record from last year as well, but sometimes I do things a little differently, so I don't know. But I record all of them, yeah. We'll try to. So for 52 A, hopefully you guys just see that you don't want to, I don't want to say these undo each other. Like, for example, you guys know if I do square root of like 5 squared, of course it's 5, right? Because the square and square root undo each other. We know that. It's kind of the same thing. You got to be a little careful with that. Like, for example, for F, that's not going to be true, just so you know. You don't want to do that. So we'll get to that in a moment. But for A, what I would do is try drawing a triangle. So what's 0.3 as a fraction? So if I call this theta, because remember, an inverse trig function is an angle. The output's always an angle. It's reversed. Whereas a normal trig function like sine, cosine, tangent, the input's the angle, the output is the ratio of two sides of a right triangle. Or on the unit circle will be the coordinates. But the coordinates are really the ratio of two sides of a triangle, because on a unit circle, isn't your hypotenuse always 1? So you're always divided by 1, right? For sine, cosine. So we usually just take the coordinates on the unit circle. But in this case, you could treat it like two sides of a right triangle, 3 and 10. And of course, that's root 91 if you were to work that out. So now, and that's theta. Theta is located right here because I set up that way. So now with sine theta, well, of course it's 0.3. Just, yeah, well, duh, of course. So you say 0.3. But let's take a look at F. Now, negative pi over 3. If you drew that, what quadrant would that be in? And what is that in degrees, by the way? Pi over 3. The reference angle in degrees. 60, good. Yeah. So if I were to draw that, or draw in the fourth quadrant, it would look like kind of like this. Now, if I use a unit circle, that would be 1. That would be negative root 3 over 2. And that'd be half. So that makes sense, right? What's the cosine of that situation here? 1/2. Good. Yeah. So now you're doing the inverse cosine of 1/2. Well, we talked about there's a default range for inverse trig functions, right? So cosine looks like this. This goes on forever, as we know. That's terrible. I can do better. And I'm getting lazy. I'm not using my iPad today. I should be, but I didn't want to upload files. So anyhow, what's the default range? Yeah, because why do we do that? That makes no sense. Let's do a different color. We want to make sure it's the inverse is a function, so it has to pass the horizontal line to it. So we restrict the domain of cosine, so the inverse of it would also be a function. So we go from 0 to pi. Well, so now if I look at inverse cosine of 1/2, what does that mean? That means that cosine theta has to equal 1/2. Or the x coordinate on the unit circle has to be 1/2. Well, where does that happen? Obviously Q1 and Q4. But I'm not going to give an answer in Q4. I'm going to give an answer in Q1 because my default range involves Q1. So what would I say my angle would be? Pi over 3. So the answer to F is pi over 3, not negative pi over 3. They don't. If you were just kind of do that, so it's negative pi over 3. That's getting kind of lazy and not truly understanding the default ranges and not respecting that. So we have to respect that. Very important. So I'd strongly suggest you be very methodical about this. Do the inside, then the outside. So kind of just be very intentional about that. Like, for example, now for B, yeah, so one can say, they undo each other. Just -4, but there's a problem. Can you do inverse cosine of -4? It's outside the default. It's also our default range for cosine. Plus, you're telling me that, okay, I'll be in Q2, and that's -4, and that's 1. That's physically impossible. I can't do that. So we just say undefined or not possible. Jump around a little bit. What if I did something with, yeah, we'll do C, what the heck. Sorry, cotan inverse tan of -√3. Okay. So I think about unit circle again, where y over x is -√3. So tan is Q1, Q4, negative pi over 2, pi over 2, non-inclusive. Actually, it's 60 degrees or negative pi over 3, I think. Yeah. So it has to be negative pi over 3. Now, cotan, isn't that the reciprocal of tangent? And so I'll do x over y instead of y over x. So that answer should be negative 1 over root 3. Or negative root 3 over 3. That one. If you want to rationalize it. And I think in the homework solution key. Yep, there we go. So before we go any further, any other questions on 52 that you guys want to ask about? We're okay with that? All right. Now for 53, you do want to draw a triangle. That's not unicircle, obviously. So look at this one, inverse cosine negative 2/3. What quadrant would I draw that in? In Q what? Q2, good. And then where would I put the negative 2? On what leg? The x. And where would the 3 go? Yeah. Can I make the 2 positive and the 3 negative? Don't do that. Always keep the hypotenuse positive. The legs will change sign depending on what's going left, right, or up, down. And if I do Pythagorean theorem, I should get root 5. Now, what's the tangent of that angle? Opposite over adjacent, so negative root 5 over 2. Am I good? Yes, 100%. Very, very important. You draw in the right place. You label correctly. So here, arctan 3/4. So your 3/4 is positive. I'm going to put in what quadrant? Q1. So that's 3 and 4. And that's 5. Well, that's lovely. So sine is just 3/5. Just get that. How about the graphs of these? How did that go? Is it okay? All right. So if you do the parent function, just shift accordingly. Just so you know, we'll keep these shifts pretty okay. I won't do a horizontal stretch. I think I'm pushing my luck if I try doing that. I don't think that's terribly important. And to be honest, they don't ask you to graph inverse trig on the AP exam. So you do need to know your graph of trig pretty well for AP calculus, but I don't think we need to really go too deep into that. Something that's important. So I'm not going to concern myself with actually, let's say, I'm not going to concern myself with doing too many transformations of that. I removed 55, 56, 57. We're going to talk about that today. We do need to talk about inverse trig for the reciprocal functions. Inverse cosecant, inverse secant, inverse cotan. A little strange, but once you get a hang of it, it's not too bad. And then what else do we have? We had 61 through 63. I think that's fair. Questions here at all? On 61, 62, or 63? We're good? Okay, so there's a lot of unicircle stuff that's going on here. And the last 87, I think, was just graphing. So I ran an equation from the graph. And I didn't specify, oh, is H positive or is A negative or positive? I mean, if you're doing tangent, I would assume you did a negative A value, right? Because that's the flip. Cotan would not change. The A value would say positive. A should have been 2, I think, for cotan, negative 2 for tangent. H is pi over 2 for tangent. For cotangent, I would have made it negative pi over 6. The period is definitely 4 pi over 3. Oh, goodness. Should that be 3/4 is the B value? Is that right? Let me double check the answer key. What? Do I have the answers here? Wait, were the answers missing for 87?
Yeah.
Oh, damn it. Oh, they are? Where? How come I don't have it? Oh, I'm looking. Oh, sorry. Okay. My bad. I was looking in the wrong place. Yes, we have the answers. Yep. That's right. It's 3/4. Yep. Oh, it's under the it's I know you're looking at the end of the pack. I did the same thing as you, Charlie. It's actually kind of in the middle because I signed a homework assignment that had 87 with some of the middle problems. That's those in the middle somewhere. My apologies for that.
Yeah.
Yeah, one of these days I'll do a better answer key. Or I'll organize better. Yeah, hopefully that's okay. All right. So any other questions? No? All right. So let's move on to the notes again. Now here's the deal. I was planning on finishing off these notes, but how are you guys feeling about inverse? Do you feel like you're still okay or kind of getting it? Okay, so I'll pump the brakes a little bit because I kind of realized for me to cover inverse cosecant, inverse secant, inverse cotan, we're still trying to make sense of inverse sine, inverse cosine, inverse tan, and to also cover the stuff near the end, which is solving equations. I think that's a heavy lift. I don't want to do that. So what we'll do is the last 3 pages or 4 pages we'll save for our next class meeting on Wednesday morning. But I do want to cover pages 27 through 27 to 30, I think is fair. I think we could do that today. So graphs of these and then do more of this inverse trig business. I'll tell you, you got notes? You're good? Yeah. Okay, cool. Yeah, always keep spares, just, okay. And before we do that, any questions on page 26? I'm not sure if we rushed it a little bit. Do you guys want to go over this again on page 26 of the notes? We're okay? All right. Okay, let's talk about inverse cosecant. Okay, it's going to get a little strange. All right. First, to start with the graph of cosecant. Okay, so it does go on forever, kind of like this. I just kind of feel like doing this right now. Okay, so just take a step back. You guys remember the graph of cosecant? And remember, there's like graph of sine, but then we have like these like U shapes that are happening. Remember sine was this? Photograph sine. Okay, not really the best looking graph, but that's sine, the blue curve. I know it's very smushed. Just go with it. But why on the notes? So I just want to graph the whole coast so you can see it. But why on the notes not show like the stuff in red here and the stuff in red here? Make it a big inverse function, because right now we just passed the horizontal line test now. Right? We're not. So it looks like we're restricting our domain of cosecant from negative pi over 2 to the pi over 2. But 0 is not included. How come 0 is not included? Cosecant is undefined at 0, right? Cosecant is 0 because that's 1 over sine 0, but sine 0 is 0. That's a problem. So the domain of cosecant is that, okay? So we're going to restrict our domain for that, so this could be a function. Now look at the graph. What's the range here? Clearly from negative infinity to negative 1 and 1 to infinity, right? So if you're going to graph y equals the inverse cosecant of x, then naturally domain range have to switch. So this will be negative pi over 2 to 0. And a domain would be that. Okay. Well, also, what I'm also going to do to help you guys out is make a table for the original and then a table for the inverse. Okay, table for the original. Um, at negative pi over 2, what's my y value on the original? -1. And of course, 0 is undefined. Of course, at pi over 2, it's 1. And just add a few more points. Looks like we're doing pi over 4, negative pi over 4. That's going to be root 2 and negative root 2, I think. Okay. So everything gets reversed. Okay, so it's reverse. Okay, I make every tick mark with 1 unit, just so you know. Um, so every tick mark's worth 1 unit. So -1, negative pi over 2. Actually, let me change the y. I'll space out like this. Okay, so -1, negative pi over 2, 1 comma pi over 2. And then also, let's see here. Sorry if I should space that a little better. That's okay. Let's go with it. Negative root 2, which is -1.414. And negative pi over 4, which is going to be over here somewhere. And then root 2, which is 1.414 pi over 4. Okay. And then given my my range, so that would be my graph for inverse cosecant. It's also the same thing as saying x equals cosecant y. So the unique angle y in the interval from negative pi over 2 to 0 union 0 pi over 2 such that cosecant y equals x is the inverse cosecant or r cosecant of x denoted, before I move the screen, wait for him to get caught up. Is everyone caught up? Okay. So denoted by the following. Or you can write arc. And domain again is from negative infinity to -1. We saw that on the graph. Union 1 to infinity. And the range from negative pi over 2 to 0 and from 0 to pi over 2. Okay, so that's, again, just a reverse. Everything we've done with cosecant. Now, let's talk about example 1. Luke's got a question.
Like on the test, transform these graphs. It's all degree.
I don't know. Well, let me think about that one. Not too crazy. Not too crazy. Actually, maybe I probably won't have you guys graph it. I do care more about example 1 and also how to evaluate. So let's take a look at example 1. Here's where it gets a little tricky. Think of this as theta, right? We talked about this already, right? Inverse any trig function equals an angle, right? The input are the ratio of the sides of a right triangle or the coordinates of the unit circle. The output's angle. So if you think about it, wouldn't this be the same thing as cosecant theta equals -2? Would you guys agree with that? Would you also agree that this is true?
No.
Okay, good. So Charlie, since you seem so confident, what do you think? What's theta going to be here?
Oh, I said so it's true.
Okay, good. Well, sine theta equals -1/2. Where would sine theta be -1/2? At Q3 or Q4, but we're going to go with Q4. So at negative pi over 6, correct. So that's the answer. Now, one thing I don't want you doing, don't do this. Don't say, well, inverse cosecant of -2 is 1 over inverse sine. That's not true. Don't do that. That's not true. Now, if I say cosecant of like pi over 6, is that 1 over sine of pi over 6? Sure, 100%. That's what we call a reciprocal trig function. For inverses, you cannot do that. Instead, what you do, so don't do this. That'd be really bad. Don't do that. Instead, what you can do is you can think of like this. Take the reciprocal of the inside. Think of the inverse sine of -1/2. If you do that, you're always going to be great. That's really what's happening. So I took a more long-winded approach to part A just so you see what's happening. Like, oh, okay, A equals theta. So cosecant theta is -2. Okay, sine theta is -1/2. Oh, yeah. Then I know what to do. So now what we can do is just say straight up, well, that's just inverse sine of what? 1 over √2. Where does that happen? You could give range or degrees. Yeah, pi over 4 or well, we want to just always give it in the first quadrant because there's a default range, 45 degrees. Actually, negative pi over 4 would have been negative. That wouldn't have counted. You could have said 3 pi over 4, but again, we have a default range we have to respect. So We want to make sure we adhere to that. Okay. Why don't you guys try part C on your own? I'll check the answer key to make sure we got it. Try part C. Okay, what's secant 2 pi over 3? I agree. Now, we said that part A. It's the same thing as inverse sine of -1/2. The default range has to be in the fourth quadrant or the first quadrant. So in this case, I would say oh, sorry. Wait one sec. Wait, secant of
It's just like a profile, right?
wait, why am I confused?
I think it's just like,
Oh, my answer key has different problem. Yes, -pi/6, right? Yeah, -pi/6. That's weird. I don't know, the answer key's off. Okay. So -pi/6. Okay. Let's keep going. But now go a little faster. All right. So it was -pi/6 because it was the same as part A. That's okay. I mean, so you need to write notes? Here. Yeah. Okay. Let's keep on moving. All right, so secant. That's graph secant. We know that's an even function. Now, we got to restrict it because we want to pass Rolls online test. Okay, so what's the domain here? 0 to pi over 2, pi over 2 to pi. Pi over 2 can't be included because it's undefined, but cosine pi over 2 is 0, but so secant's undefined. The range here, we see that. So now if I do x equals secant y, switch x and y, of course, if I isolate y is going to be the inverse secant of x. We know this. Domain range will also switch. So going from -infinity to -1. One to infinity. And then I'm going from, excuse me. And let me space it out a little bit better than last time. Yikes. Let's fix that. Okay. Let's make a little table for the original. Always a good idea. So there's a point at 0, 1. Right, because secant of 0 is 1. That makes sense. Pi -1. Pi over 2 undefined. Pi over 4 is √2. And 3 pi over 4 -√2. we reverse. One zero, negative 1 pi, root 2 pi over 4, negative root 2, 3 pi over 4. And obviously, y is not going to be pi over 2. So what do you think is going to happen with pi over 2? There's actually horizontal asymptote. And actually, I think I forgot to show you that for inverse cosecant. Where would the horizontal asymptote be for the inverse cosecant? Based on how I drew it. If I drew a horizontal asymptote for inverse cosecant, the x-axis, yeah, y equals 0. Yeah, I forgot to do that. That's because x equals 0 was the vertical asymptote, right? So let's do it. We're at 1 comma 0, root 2 pi over 4. So look like that. Then we're at negative 1 pi, negative root 2, 3 pi over 4. It will look like that. Okay. So the unique y in the interval from 0 to pi over 2 union. And notice it's the same default range we're using for the most part, but we're excluding pi over 2. But same default range for inverse cosine. Likewise for the inverse cosecant compared to inverse sine. And we can denote it like this. Or like this. Okay. And domain range, I don't feel like writing again. You guys know. There's a domain, there's a range. You guys know. Just copy it down. Okay. So inverse secant of negative 1. Remember, it's the same thing as saying the inverse cosine of 1 over negative 1. Well, of course, that's still negative 1. Where does that happen? Where's cosine negative 1 on the unit circle?
Pi.
Pi. So answer is pi. Now here, I'm going to do the cosecant of the inverse cosine of negative 1 over root 2. Inverse cosine. Default range is from 0 to pi. So what quadrant am I in if I'm doing inverse cosine negative 1 over root 2? And what's the angle associated with that? Where's the x coordinate negative 1 over root 2 or negative root 2 over 2? 3 pi over 4. Good. So now I got to do the cosecant of 3 pi over 4, which is 1 over sine of 3 pi over 4. Well, what's sine 3 pi over 4? Root 2 over 2 or 1 over root 2. If you flip it and then rationalize, it's just root 2, just so you know. Just get root 2. So unit circle, you got to be pretty fluid with it, as you can tell. Ooh, love 3. That's a good one. Test style problem. Love it. Let's talk about that one next. Okay. She has to write us an expression. By the way, any questions about A or B? We're okay. How's the pacing's okay? Not going too fast. Trying to be patient here. Okay. Well, as long as the other students. Okay. That's just getting very animated. Okay, so that's data, right? Any inverse trig function is data. So what does that mean? That means that secant theta equals what? 1 over t. Does that make sense? How I reverse that, right? Makes sense. Does that matter? That t is greater than 0? It doesn't matter why. Doesn't matter. Which quadrant? Yes, those are the quadrant. Yes, exactly. If it was negative, then I have to put it, then I have to adjust it correctly, right? Now remember, the default range for secant is 0 to pi, right? But pi over 2 is excluded because you can't take cosine pi, you can't take secant pi over 2. So I'm gonna put this in Q1. Now if we're negative, I would put it in Q2, just so you know. If we're negative, I would put it in Q2. But because this is positive, I have to be in Q1. So that does matter. So I'll put in Q1. Now think about it. If secant theta is 1 over t, isn't cosine theta t over 1? So, and that's theta. Where am I going to put the t and the 1 then? Yeah, and 1 is here. Okay. Okay. So far, okay. We're good. We're just kind of take our time. That's theta. That's positive of Q1. See if there's 1 over t. Cosine is t over 1. Opposite, sorry, adjacent by hypotenuse. Adjacent hypotenuse. How do I get the opposite? What am I going to do? Yeah, in terms of t. Now you can just choose an arbitrary letter. I don't care. Choose your favorite letter. Doesn't matter to me. Just don't do t. So a squared plus t squared equals 1 squared. What does a squared equal? And what does a equal? Correct. And this is why you have to be in the right quadrant, because what if somehow that vertical leg was pointing down? Then I have to put a negative out front, because technically speaking, that's plus or minus. That we're pointing down, I'd better make that negative. Just say that. If we have a situation like that. Yeah, I like this problem because it really kind of forces you to really understand what's going on with the orientation of the triangle. Now, what's a sign here? So the actual question we need to answer is this. Just root 1 minus t squared. And that's the final answer. Final answer. Yep. I like it because it does a lot of neat connections. Like back to new circle. Like back to quick functions. Like back to Sumatoa. Like back to Pythagorean theorem. Like back to plus minus stuff. It's just a really nice connection. Okay, we're good. Yeah, is your brain hurting now? Good. Good. That's the whole point. All right.
Classroom.
Next up. Inverse cotan. This is a little strange. Okay. We have asymptotes here and here. And we just stick with that cycle. Emma, go, yeah.
Is like in the inverse of a number.
Well, inverse of a number. Well, what do you mean by inverse of a number? Well, yeah, I mean, technically, what you're doing is you're doing the opposite operation, sure, in essence. But of course, we're doing something way more abstract than the inverse of addition or subtraction or multiplication division. So, or inverse functions in general, which this is definitely a little more abstract. That's what's happening here. But as long as we know domain range of the original, we can get domain range of the inverse, right? Like obviously it's 0 pi negative infinity to infinity. So I'm going to do this. Domain will be from negative infinity to infinity now. And the range will be from 0 to pi. Non-inclusive. And let's draw actually I'll do, yeah, that'll be pi. Okay. Let's make a little table here. Remember, we're doing x equals cotan y, which is same thing as saying y equals inverse cotan of x. Obviously, there's a point pi over 2 comma 0. A point at pi over 4 comma 1. And 3 pi over 4 comma negative 1. And of course, at 0 and pi, it's undefined. So you have 2 vertical asymptotes. So how many horizontal asymptotes will I have? 2. Yeah, you got it. Right here. And so up down, it's going to be more what? Yeah, more sideways. Yeah, 100%. So I make my little table. 0, pi over 2. So there we go. 1, pi over 4. There you go. See how lovely this is? Comes out really nice. 1, negative 1, 3 pi over 4. And if you were to superimpose this over here, it would be a reflection of y with x. You would see that inflection for yourself. Okay. So now the unique angle from 0 to pi. Now this is where it's a little funny, guys. It's a little funny because the default range for inverse tan was negative pi over 2 to pi over 2. Right? We looked at the right half of the circle. And inverse cosecant and inverse secant had the same default ranges as their counterparts, inverse sine, inverse cosine. This default range is not negative pi over 2 to pi over 2. It's actually 0 to pi. That's because of the graph that we're seeing. Because of the graph we're seeing from 0 to pi, for the domain for the original cotangent, for the inverse, it's gonna be a little funny. So it's a different default range compared to inverse tan, just so you know. The default range for inverse cotan is 0 to pi. So you're gonna look at the first and second quadrants for inverse cotan, not the first and fourth like we did for inverse tan. Keep that in mind. It's a little different. You have inverse cotan of x, or you can do arc cotan of x. You can write either way. And range, again, all real numbers. I'm just getting kind of lazy. And 0 to pi. And again, why do I restrict the cotan? Because if I didn't, let's just keep going up and down for everyone. It's how it would itself. So that's the graph of inverse cotan. Okay, now I think you guys are ready to do some of these on your own. We've got about 10 more minutes left. Let's see if you guys can handle these 5 problems. And I think what we'll do is we meet again Wednesday and then Thursday. I'll do a homework quiz on Thursday. I won't do homework quiz on Thursday. As long as I don't have to know CLG or have another tree limp fall in my car, I have time. And I love the CLG was great. I loved it, but the car thing was a pain in the ass. Yeah.
How many cars got hit?
3.
Yours is one.
I got the worst.
Really?
Yeah. Beginning of Y period on last Thursday. Right when C period was over. Actually, right for you guys. Yes. You guys left. I was talking to Mr. Davidson, and then I thought I heard like fireworks. I thought it was fireworks. I was like, what seniors lighting fireworks in the senior lot? Because it's so loud. And then I look and I literally see the tree coming down, and and then I hear my car alarm. Like, that's not good.
Yeah.
Yeah, and I was the first person here on Thursday morning because I had a call I had to take, and I didn't want to take to my house and hit traffic afterwards. So I was here at 6 a.m. And of all the spots I chose, that's the one spot I chose. I could choose so many spots all throughout this campus. I chose that one spot. That's okay. The insurance will take care of it, so no one got hurt. But yeah, but that's scary because if I was out there at 5 minutes later, like putting stuff in my trunk, that could have,
Yeah.
yeah, that'd been scary.
Oh,
It's just the weight of it. The trees are pretty old. Some of the trees are older than the campus itself. Um, we have an arborist that actually does check the trees. Like we actually spend hundreds of thousands of dollars on an arborist. Like we have a contract, but you just don't know. Like in between checkups, the tree just sometimes will get disease or old or, and it literally was just the weight of the limb just was too heavy
dang.
because there's no. It was a perfect day. Like there was no rain, there's no wind. Have you guys seen pictures of it, my car? Here, I'll show you guys some pictures while you guys are working. Oh yeah, it totally demolished my car. Yeah. If it could do that kind of thing, imagine what it could do to yourself, right? Man, it's really scary. I'm glad I'm glad my kids were in the car. That'd be even scarier. I was able to get my stuff out, which is good. Yeah, here we go. Yeah, you can see I have very detailed records of my car. So like I've had this car for quite some time. Anyway, yeah, and your mom parks in the same place too sometimes. Yeah, your mom got lucky. Yeah, look at that. And actually, I didn't notice the irony. So I did my grad school at Stanford, and you know what the Stanford mascot is? A tree, right?
Alumni.
Yeah, exactly. Right. I have some videos. I'll download the videos when I get a chance. I'll upload to my computer. But the Menlo Fire Department, they're great. They came by and like chopped. They got their chainsaws and they're chopping up. My kids thought it was fun watching those videos, and they like having a rental car. Like, Dad, you got a cool car. Because I have an SUV right now, or I'm renting. But yeah, you can see the car is literally inside. I mean, sorry, the tree is literally inside the car. Exactly, it was. And then that's Mr. Donahoe's car. And then Mr. Victoria's car's over there. Yeah, you can see that. I just don't think you could replace that. I just
Yeah, what happened there is they're just like vertical.
yeah, they didn't have the roof. The cars are fine because the roof is part of the frame. So like I've had my share of car accidents. Like if you get the front, the hood, or the trunk, they could replace that. It's usually about 2 or 3 grand to replace. My car has 180,000 miles and it's 2013 model,
Yeah.
so it's probably worth 7,500 to 8,000 tops. I think it's gonna cost more 8,000 to fix that.
So I just gonna do a car.
So they'll have to cash. They'll just give me the cash value, then I just go buy a new car. So, which I wasn't quite ready to do, but yeah. Anyhow,
At least you're getting upgrade now.
I can, but I don't know if I want a car payment, so I don't know yet. My parents have an extra spare car I can use. I might just use my mom's car because she doesn't really drive anymore. So yeah, you can see that they had to chop that off. There are more in pictures I can show. It was pretty how to fall. It just snapped. Just like
It was like, okay, oh.
well the thing is that there's other like branches that are really heavy sometimes. So, like when you take good care of a tree, you want to prune it. But like this could easily snap if there's too much weight up top. If there's heavy winds, it's just like float, the tree will be swaying, that can snap anytime. Actually, this happened 12 years ago. So I was actually on campus on a Sunday morning. I was doing an ST class here. And this is the old building before this building. So we were a one-story building and it had a little courtyard. And I could see from where the seniors play cornhole and their little golfing game, I could see this giant oak tree. No, I think it was a redwood tree. Can't remember actually. It might have been a birch tree actually. Because redwood trees don't really fall. They're pretty sturdy. This fell in September in the fall. So I'm guessing when there's like a lot of dry weather, these trees just don't really, yeah. So you can see, and this tree was really long. And if you guys can't tell, you guys recognize that building? Yeah. Those fraction walls being constructed in 2013. Homer was only 4 years old back then. Yeah, and I heard this huge booming sound. I saw like a bunch of smoke come up, and I was like, what was that? I thought maybe like when the steel beams fell down or when the cranes collapsed. And it was yeah, you can see how long it is. And that's where the seniors eat lunch. Like they could have knocked out several kids. Yeah. You can see this hollow inside.
Do you have a photo of the? Was this a Seagull building? What was this called?
Before this is called the Siegel Building. Yeah.
Wow.
I'm gonna have to pull some off. Mr. Bell probably would have. He's pretty good at keeping archives.
Mhm.
It was okay building, but it was built in the 70s, and we started having a lot of leaks. And then just Mr. Joy wants to raise more money, raise like 100 million, like that. Just well, not like that. He did work hard, but he raised 100 million for Homer and the Tower Middle School. Then 10 years later, raised more money. So he's pretty impressive how he can do that. Anyway, let's go through these problems here.
Can you show doing A and B?
Sure.
Oh, yeah, no, that can still be. Isn't tan negative half to positive? That's what you think about it. But either way, but tan is still using that rate. So tan is higher than is zero. But that also you go
Okay, you guys are cool with D&E?
tangent.
I guess we'll work through it.
Oh,
let me do
I
A.
understand.
Okay, sine 5 pi over 6. Let me do it in my head. That's 1/2. So that's like the reference angle is 30 degrees. So sine 5 pi over 6 is 1/2. 2 times half is 1. You're doing inverse sine of 1. Where's the y coordinate 1 in the unit circle? The y would be at 90 degrees. That's why it's pi over 2. So think of that. Inverse cosecant of -2. That's the same as inverse sine of -1/2. That's going to happen at Q2. No, sorry, Q4, which is negative pi over 6. Cosine of that's √2. So you really want to think about the unit circle for that one. Again, that's going to be inverse sine of -1/2. Where's y coordinate -1/2 at negative pi over 6? And then cosine of that would be the x coordinate there, which is √2. So if I actually draw the unit circle, that might be the best way to visualize it. Draw the unit circle. That's inverse sine of -1/2. Hopefully we could see it has to be right here. Does that make sense for part B? And then let me do part A again through the same methodology. 5 pi over 6. Ooh, almost perfect circle. Right here. That's going to be what is it again? Negative √3/2 and 1/2. So you got to do the y coordinate, so it's 2 times 1/2, which is 1. Inverse sine of 1, of course, 90 degrees. Or pi over 2. And of course, that's -1 over, I won't say of course, but that's inverse cosine of negative √3/2. And then that's what 150. Tangent 150 will be that. Okay, we spent too long doing show and tell with trees in our campus. But I think you guys get the idea how to handle these. We'll talk more about this. This might be a nice little segue. We can talk about this stuff. But homework, I'll put in Schoology. It's gonna be a bunch of inverse, cosecant, secant, cotangent stuff. Yeah, so that's pretty much it.
Thank you.
Yep.